Okay, hi guys. So in this video lecture, we'll be taking on with some more examples on reaction of alkenes with HBr. Okay, so let's get started. So we have our first example as uh, this is a CS3 and double bond here and CH2. Okay, so we reacted it with HBr in presence of CCl4. So what would be the products formed? So if you know that the intermediate would be a positive sign, positive carbocation formation at positively charged carbon atom or carbocation formation at this carbon. So Br will attack either in from above the plane or from behind the plane. So if it attaches above the plane, then this would be the compound, and if it attacks below the plane, then this would be the structure. Mind you, this CS3 was already above the plane. It was already given in the compound. Okay, so let's take some more example. We have this and CS3 is attached here. We react it with HBr, presence of CCl4. So what compound would be forming here? So you know the positive charge would be forming here. So carbocation with formation at here will be here. So Br can either attach itself here or we can have something like Br and CS3. So let's count the number of carbon atoms when we go from here, and if we go from here, we will have the same groups. Okay, so if you actually rotate this cyclohexane 180 degree across this perpendicular plane, then you will get the mirror image of the first compound. Okay, so these two compounds are enantiomers. Okay, third is, so I repeat that there is no chiral center involved here. The stereogenic area is the cyclohexane ring itself. What about this case? Here we have HBr CCl4. Then carbocation formation would be at this position. Why? Because of more number of alpha hydrogen. So let's say we have this compound. Then this is a dark bond here. CH3 can be above the plane when Br attacks below the plane, and Br can be above the plane and when it attacks above the plane. Okay, so these two are diastereomers. Okay, let's consider the case for this. We have two CH3 here. So what would happen if we have HBr CCl4 here? So carbocation formation would be either at this place or at this place. Which of the two cases it would be there? The carbocation formation would be here. Why? Because of the inductive effect of this. There will not be any H minus shift or H plus CH3 minus shift, because even if the carbocation comes here, it would have the same number or lesser number of alpha hydrogens. So what I am saying is, first we can have a carbocation formation at this position, or better we can have at this position. So if it is at this position, number of alpha hydrogen here is 1 2 3 4, and number of alpha hydrogen here are also 1 2 3 4. Okay, so but here it is having more inductive effect because of these two CS3 groups. So this would be a minor product in intermediate, this would be a major product. So now here also can we have H minus shift or CH3 minus shift, so that the carbocation comes here and here we can attach the H minus or CH3. So even if the carbocation comes here, then the number of alpha hydrogen for this carbon for this carbon to have positive charge would be less than already which is present here. Okay, so let me draw and give the clarity to you, that for example, if it is a CH3 here, first of all CH3 minus will not happen, only H minus shift can happen because the nearest is H minus. Okay, so even if the H minus shift does happen, to make this as positively charged, and we have two CH3 here. Okay, so how many number of alpha hydrogen are there? 1 and 2, 3 alpha only. So there is, the reaction will go in backward direction, because this was more stable as it was having 4 alpha hydrogen, unlike this which is only having 3 alpha hydrogen. And from here only the Br attack will take place, because this is the stable product. The Br minus will attack this carbon, so we will have something like 2 CH3s here. So Br can either attack from above the plane or from below the plane. So this and this would be the, so the mixture is racemic or they are enantiomers. Let's look at the fifth example. Here we have double bond here, CH3 here and CH3 here. Okay, so we attack it with HBr in presence of CCl4. So what will happen is we will get a carbocation at this position or at this position. So both would be identical only, because the compound has a plane of symmetry. Now Br minus will attack to this carbocation, so we will have range of products, like we can have either CH3 above the plane, this Br minus attacks below the plane and CH3 comes above the plane, or CH3, this is above the plane, this Br attacks above the plane and CH3 is below the plane. Similarly, if we have CH3 as below the plane, this Br as above the plane and CH3 below the plane. And the fourth case, I hope you are able to guess it by now. Okay, so we found 4 compounds, and it should be the 4 compound because these 2 are the chiral centers which are present here. So 2 to the power 2 is there any problem in when I'm drawing all these structures? Would we have all these 4 compounds? Yes. Why? Because you can see that this compound is having plane of symmetry, but it will lose its plane of symmetry once Br is attached to the group. So this compound will be unsymmetrical or asymmetrical. Okay, so let us look at some more examples. Let us look at this example. Okay, so we reacted with HBr, CCl4. So let me draw the intermediate first. CH3. Intermediate would be this carbocation, and now it can go under CH3 minus shift. Okay, to get itself okay. So now here Br minus will attack to form something like Br CH3. Okay, so this would be the final product formed. And how many you can see this only no chiral compound is chiral center is there in this compound, so this will be the only major product. No stereoisomers. Okay, Let us see at the 7th example. Here we have this, and if we react it with DH, it will have, let's say, X number of products. So the question is, what is X? Okay, so if you react it with the DH, so what will happen is, I beg your pardon, this make it DCl. Okay, so in this case, positively charged will come here, and D would be getting attached here. So then Cl minus will attack this carbocation to form something like this. Okay, so now you can see there are two chiral centers, so 2 to the power 2 would be the total number of stereoisomers, so X would be 4. Okay, now let's see another example. We have this. If we react it with HBr in presence of CCl4, we will have a carbocation here, and one thing here is, if we have the carbocation at this place, then it can actually undergo resonating structures. Okay, so this presently carbocation has presently 4 alpha hydrogen, but if it undergoes H minus shift, we can have something like here is the carbocation, and here all the resonating structures. It is having 2 alpha hydrogen plus resonance, and as resonance is given higher priority over hyperconjugation, this product would be in the this intermediate formation would be in the forward direction. So now the hyperconjugation can take place to give rise to stabilize the compound overall, and hence at each position where carbocation is formed in this ring, Cl minus will attack in all those positions, and we would have stereoisomers from them. Okay, so you can draw it and you can see for yourself. Okay, so now let's take another example wherein you need to draw all the possible isomers of C4H8, only alkene isomers. Okay, so we will get X types of let's suppose now the question is, you react all the isomers of alkene C4H8 and you reacted with HBrCCl4, and you get X types of Markovnikov products. X types of Markovnikov products. Okay, so what would be the value of X? That you have to determine. Okay, so we can have something like this. Second, we can have this. These are only two possibilities. Okay, so we react it with HBr, so we'll get Br here, and if we react it with this, we'll get the same compound with Vr here possibly. Okay, so this is a chiral center here, and same for here. So in this case, this is identical to this, so you don't need to consider this. So X in this case would be 2. It will show stereoisomerism. Okay, so this brings us to the end of this lecture. In the next lecture, we'll be seeing reaction of alkene with H2. Okay, so till then, good luck and goodbye.